开录了。
Yes, start.
To all my friends, the night is young, the music's loud, they're playing our song. Nowhere else that I belong than here with you. Than here with you. I remember this night got started when you entered. I hope we can get a little closer, maybe even get to know your name. I wanna hear the music so loud. Get some drinks inside me right now. So baby, let it go. You had me at hello. Let's raise our glass and toast. DJ, play that one song. To all my before we know it. If you got some money, time to blow it. Cause the way you got me feeling so sick. Days of the night away with you, with you, with you. Yeah, nobody here is sober.
So I cannot bring the home computer. Oh, you start?
I think start, yes.
Okay, now we'll start today. Okay. So today we are going to create a C++ project. We try to use the API, a CVOD API. So we want to learn how to create a project and include other people's code. Okay? So for example, I put the CVOD in my workshop. Okay? The CVOD is here. Okay? So I will create a project. Okay, for example, I can call CVOD, for example, demo. Okay, I will create. So let me show you how to create. Okay, and I will use. So I will use 2008 to create it. So you can use anyway. It doesn't matter. Okay, it's similar. For example, if you use Visual Studio 2008, and then you will go to the new to create a project. Okay? And of course, this project should be Visual C++ project. Okay? And there are many choices, so which one we should choose. And we can, so if you don't have want to create some graphic user interface, then you can create two choices. One is empty. Okay? So you can create an empty project. So somewhere, okay. General. Okay? You can general create an empty project. Okay? Or you can create a command line, so console application. Okay? This is like DOS, okay, command. And the difference is if you have a DOS console application, then you can display some information on that window. Okay? If it's empty, then your data no place to display. So maybe the good choice is this one, okay? Console application. And you need a project given name. For example, right today we want to create a simulation project for this chemical reaction. So give a name, for example, you can say simulation, okay? Okay. For example, I will create a simulation project, and this is the place where you should go, okay? I just put the same place as workshop, doesn't matter, okay? You can select any place you like, okay? Once you're ready, then you just say, okay. So it will give you this result, but that's basically you don't need to go loop all the way, you just finish, okay? No one care. In this case, it will create an empty project. Okay. This empty project is here, so if you compile this empty project, it's supposed to work. Okay. But it didn't do anything. Okay. This is an empty project. Okay. So no error, right? Succeed. So now we want to include the VOD application API. So there are two ways to include the application API. Okay. One way, some people only provide you head file and give you library and DLL, dynamic, okay, dynamic link library. So in this project, the people is good enough. They give us the source code. Okay, that would even be better. Okay, just include the head file, also source code. Okay, so I would say I put the code here, CVOD. This one have the source code and head file. So all is here. So good. So I will include this in our project. Okay.
Put where?
So now I will show you. So head file will go to head file. Okay. Source file will go to source file. Okay. And here you just add existing items because item is existing. So you just add existing item. Go to the place workshop. We have a CVOD. Find the place you put the code. Then click the type. Find all those head files. Okay. So here is all the head files. Use the shift. Okay. Select all of them. Okay. You say add. Now all your head files is going to here. Okay. And now we need the source code. Okay. So add existing source code here. So now go to here, download a little bit. So we need the source code, source file. Okay. All the source file shift. And then you say add. Okay. So now this CVOD API is included in our project. Okay. Now the problem is, our project is a C++ project, and this code is C code.
It works.
Okay, it's .c. It works. Okay, because we have this we call pre-processor head file. So if you compile, maybe give you some error. If I compile this, for example, or compile this, okay, it will give you error, failed, because it's supposed the file need pre-compiled header files, and this one we don't have. So easy. Select. Maybe I can select all of them. Select all of them. Instead, this one is pre-preset. So we click here all the way to here. Okay. Hopefully I can. Okay. The dialog is in different window. Okay. Dialog is here. Okay, here we just remove the preprocessor. Okay, so here we don't need a preprocessor. So here, this one. Okay, so don't use pre-compiled header. So there's no this. So make it to not use it. Okay, then you done. Okay. Okay, it's C++. Have a choice, pre-compiled headers. Okay, and this one we don't need. So you just select not using pre-compiled. Okay, originally it's this one, so it should be this. Then you say okay. Now you're ready. Okay, in this case you can compile. At least you can compile this code. There's no error. Okay, no error. Everything succeeds. So, but we haven't used their API yet, right? So the whole project is empty. We want our code to call this CVOD solve the chemical reactions. Okay, so this is our equation. We try to solve this equation. Okay, and in order to solve the equation, all we need just type this. Okay, we have you remember we created this guy, right? What is this? This is simulator main function. Okay, we want this main function. Okay, we want to change it. No, we're not changing. We just add those code here. Then we compile this main. Will eventually will call the solver code and give you the result. Okay, so now, so very easy. So we will change something here. So we need to include a couple of stuff here, right? So you see this one? What does it include? So we can include this. Okay, you can forget about this example, like the comments. Okay, we need stdio.h, right? We need a couple of so. Okay, so we just change this one. So now this is a Windows created a little bit different from the Linux now. The underscore T main and this underscore T character star argument. It's a little bit different. This is because Windows can support Chinese, can support not just ASCII code. ASCII code is more English. Okay, so you can change it. Okay. You can change it, make it like here just character. It's also fine. Okay, okay, you just CHAR. Okay, that's okay. Okay, you can change this and you can compile it, and no problem. Okay, this back to the ASCII code instead of underscore T character that is for Chinese as well. Okay, I don't know the.
The compile it.
Andy, did you try this before? Understand this or not?
Yes.
You understand this means, right?
Yes.
It's argument.
The
When you're running a program, yeah. Yes, you can.
Transfer some
Yes,
information
yes.
to the program
Exactly.
before you
Yes.
run it.
Yeah. So this is like your program have a name. So this is how many arguments. Okay. The first argument is the program name. So if more than one, then here give you the argument. So you can use Linux or Unix the command is in program name. You can normally use the slash like v slash h slash p whatever. That's the argument. We will normally here we will add a code, analyze this guy. Now first the count is how many it is. Based on this, analyze this line. This is a command line. We load each argument. And they analyze, okay, if it's normally, for example, your command is on H, it's like a help, okay, it's P or whatever, V. So we will analyze this, but later on we will talk about how to analyze this command. Okay, very easy. Yes.
Some compile error.
Compiler because you I mean,
Yeah.
well, you haven't finished it. You need more. Oh, you mean this one?
Yeah.
Yeah, good. You know why?
Why?
Because we didn't tell where this program coming from. Good question. Okay.
Oh.
You need settings. Okay. Go to the property where your header file is. Okay. Here we'll give you general. We need include dependencies, directories, the additional include directories because. Your project don't know the header file is, so you need here. You need to find out. Give this ID and try to find out where this code is. Okay, your code is here. Okay, and this is your code. So you need a folder. Tell this project and. Add this additional include directory to your project. Okay, your project, click the project, and go to the C++. They have a general. Okay, and this is supposed to place. You want to include the header file, right? Some other people's code. Tell this project. Now code is in this place. Okay, yours may be different place. Okay, tell this place, and then you say, okay, now yours should be okay. So now I can add.
Go to the project.
Go to the project, okay, and have a property. Okay, property, it will pop up with this one, C++. This is the source code, and this part for linker, which means we will try to find out where is library. You may have some extra library. Okay, so Andy is good to learn how to include include this library, how to include the other people's code. So you need to tell what this code comes from. Sometimes it's multiple sources. You can put different places. Okay? So you don't need to copy to one place. So your folder can be multiple places. Okay? So here you have multiple sources. Okay? So in this case,
How to choose?
Now. Now here you can click another line.
Oh.
So give another. So you have many. Okay? So click one line, it will give you, let's say you have another code maybe from another folder. Okay? This will tell you where is the folder is. In this case, we only have, now we include one folder, right? Later on, this project become interesting. We will add more folders, more stuff. Okay? So this is one. Okay. Do you know how to do? Go to the project.
Already no error.
Huh?
Already works.
No error, right?
I don't have the code.
Code on Q.
Oh, QQ. QQ
Yeah.
group, you can download this VOD, COD.
Yeah.
Or you can copy, maybe, do you have a U drive? Just copy, then even faster. Or you can copy.
Go on Q.
Okay. Okay, now if we know the folder, now the good thing is we can type in this code. Okay? So in order to, okay, you can save a little bit of time. Okay? I have another code here. I already have, so here I have something here. So source code, I have one code we call reaction. Okay, in this item. So I have a reaction here. Okay, and this code is basically, I already have something here. So this code is the original, I wrote something. So here, I can copy some of this include file here. So first one, CVOD dance, vector is not here, and vector. I can use vector, I can use dance. So I can copy this couple of lines several different times, okay? You can copy this. Or I can type directly because our code is here, right? So I can include something here. And here we use vector instead of n vector, but doesn't matter, you can use vector with n vector. So let me see, vector. Do we have a vector?
Yes.
Okay, now, second we define a constant variable, which is n-eq, which is harmony equation. Okay, we have, this is n-eq equal to 3, now define. N-eq is a constant. Okay, define a constant equal to 3. Okay, which means you can use NEC or you can use 3. Okay? So if I
右下周边区
左边区没有啊？
没有啊，
好奇。
this one.
我一下。
I should get rid of this. This I should get rid of. Remove. Only this. I just copy that. Okay. So, what error? Cannot open include file vector. So there's no vector. It's n vector. Everything is a vector.
But the vector you should have it.
Vector is in the CVOD we call n vector. It's not vector. So this is some error. Okay. Should be C vector. You C program. The library provide vector, but it's not right. It's use so it should be n vector. Okay. Okay. So now it's no error, right? So now we will add more code here. Okay. We have the include our function yet, right? Before we include our function, we need static. Now we need this define a function. Okay. Static. Right. Static VYD F. Okay. This is integer n real. Now here real is the same as double. Okay. N vector is y n vector y dot and VYD star f A 的。So this is just define a function declaration. We declare a function. Okay? We don't have this function yet. This is just a define function. Okay? We will provide this function. Okay? Okay, that's code not that long, just a little bit, right? You know what this is f function? This will give our function. 3 equations we'll put in this function. Okay? You have like
3.
no. In this case it's 3. Our example is 3. Remember at the very beginning example, dy1 dt equal to something, dy2 see dt, dy3 dt, right? That's the equation. This equation eventually will put in this function. Okay. So first we will define a function declaration. Then in the main program, we will start doing something. Okay. We will type in real. Now this is.
I think a vector should be like a parenthesis. This is maybe error. This code.
This code is should end.
No, not a vector. I think a vector should include in this thing, not a quotation mark, but this one.
But this is end vector is this.
This
This one.
special
Here
head
we have a vector somewhere here.
It's a special vector.
Yeah. If you use a C vector, then you should be like this.
Yes.
Yeah. This one a vector means I will use this one to provide a vector. Okay. Instead of our vector, a C vector. Okay. Once we type in, we will explain this. Okay.
This is just the 2 arrays, right?
Yeah.
Nothing
Array.
else.
So right here, array. Yes.
Nothing new else.
Now this one will call CBOD solve. Okay, the MEM is will assign a memory. This is a memory pointer. And then we will have an output, input output here. Okay. IOUT is okay, output flag. Output okay. So you can type a few and you can probably see is any errors in or not. We hope no error. So already have a fail, so something's wrong. Oh, I typed it wrong. So this basically.
Why you wrong? I'm right here.
I'm
You should add a comma.
This is the comment. Okay. So I wrote something. Type it. Okay. So here, oh, have another error.
Should work. Some error.
Why does it this error? Integer and real t and vector. What error?
Vector, N vector, big capital letter.
Huh?
Vector, the vector, it should be the first.
Oh, this one is
Yes.
wrong. Yeah, you have it. So okay, this should be okay. So it's low. Oh, and it's okay. Warning, because we didn't use this on reference because we haven't used it yet. We haven't finished yet. Okay, we are still in the middle. Okay, we haven't called a simulation program yet. Okay, so simulation program is the lower part a little bit. Okay, so y equal to this. This is allocate a vector y and absolute. So we'll. Now we will create 3 functions. So new, n equals 3. L equal to N V U A E Q A E L. Okay, this is assigned memory space. Okay, this is NVD, so create a vector, enter is wrong, NEQ, not NEW. Okay, so now next we want to initialize some value. Okay, so initialize our initial value. Initial value is N V I T H 0 equal to 1.0. Okay. V I T H second variables equal to 0. Okay. Third one N V I T H Y, so the second variable also equal to 0. So initialize the value. Okay. So this we try to solve this y1, y2, y3, and okay, and we will this initialize value. Okay. So this should be okay, but we still haven't called the function yet. So still no problem, no error. Okay. So good, no succeeded. So now we will call. Okay, we will close. Haven't yet. Okay, we will go to call CVOD memory allocate and to initialize our solver. Okay, initialize CVOD solver. So in this case is what tolerance REL. Let me go to the REL TOL equal to 0.1 E minus 4. So this is the small number, and N V I T H, so ABS TOL equal to 1 E minus 8. This is how accurately you want your solution. Okay, so give some this value, constant value. So each now. So which means we have 3 absolute tolerance. So which means each variable, the accuracy is a little different. One is 1e minus 8, which means 1.010, the power is minus 8. So it's a pretty small number. Okay. Another one is even the minus 14, so even smaller. Okay, this is the 4th. So second and the third, you can make a copy. Okay. It's similar.
So NVITH is initialized.
Initial, yes.
Initialized what thing?
This tolerance, which means is one value is n and n plus the value. If the reference is difference is less than this value, we will stop. Okay, this is tolerance. Now we calculate value. We try to iterate to close to our solution. Okay. If 2 values is close less than this value, it will stop, which means it meet our requirements. This is 14, right? 14. Another one is 6, right? So 6. So okay. So this is 3 tolerance. Okay. This is relative tolerance for the whole solution. Okay. So we have 3 arguments. Okay. Y1, Y2, Y3. Y0, Y1, Y2. Okay. And now we will initialize a memory space for our solver. So it's called CVOD memory. Okay. Here. Right. We will need to create a memory space, create a solver. CVOD. Now we will create a memory, and this memory equal to CVOD memory allocated. And we have 3 equations. Now this is a function f. So the function will read our function, okay, it will use BDF algorithm to try to calculate use Newton iterative method. Newton, okay.
What's the BDF is?
BDF is how to calculate. It's algorithm.
Oh.
Okay, how to solve your equation. So this will tell you each place what value you should put. Okay. Now we go to SV and the second is relative error, right? Relative error is point. It's relative TOL, right? It's a pointer. And now it's absolute value. And this
Why
one.
you need to pass the pointer to it, actually?
I will tell you why pointer, not the value. It will make your program more efficient. Yeah, I will explain to you right away. Okay. And this memory space supposed to be. You can, if you think it's too long, then you can go to the second one. Okay, like this. Okay. So anything wrong? So fail. So I typed something is wrong. I don't have REL TOL, or I missed something. Undefined declare REL TOL. Do I type something wrong? It says this one I didn't repeat. I didn't declare somewhere. Oh, here. This is wrong. I typed it twice. Okay, this is REL TOL. Okay. So now, okay, what is error? Oh, I don't have f yet. Okay, great. In this case, we try to use f. F is a function, right? And I didn't provide the code, so it will complain. It says your code, where is your code? Now you want to try to use f, it will complain. But if you don't have this line, it will not complain, because it says that f, no one uses. So it doesn't matter. Now you use this f is a function. It's not just one function. It's so now I have the defined function here. The function, the next page, is not as hard. It's a static function. Okay, I can put it here. It's a static function f view ID, which means there's no okay. And I need put the argument. Okay, so argument is the first is the integer n, real number p, 2 vectors n, v vector y n v vector y dot is a derivative, okay? F data. Okay, now here we will put our function here, okay? So this code is pretty smart. They know your function, and based on your function, they can solve your function, okay? Now function right now we use real value y1, y2. Y3, YD1 and YD3, right? Y1 equal to and TH Y0. Y2 means NVIT. So it's connected to our vector. Okay? Y value is connected to our which which vector is corresponding to your variables. Okay? Because eventually your value will assign to pass to the vector. Okay? And then y d1 is means y dy1 dt. Y d1 means like this. Okay? This here y d1. Y d1 means dy dt. dy1 dt. Right? Just in the program you cannot divide by dt. That's a mess up. So here's dy1 is equal yd1, not ydi. Okay. Equal to, now we will use vector to calculate our function. T h y dot. Oh, sorry. Basically here just write your program here. 0.04 multiply y1. Our
This is the initial value or derivative the value.
yeah,
Initial value. The
we-
original function.
initial value, which one? This is original your mathematical equation.
Oh,
This is your mathematical equation.
so
This is like dy1 dt equal to
Oh,
this.
right.
Okay? And another one dy3 dt or whatever. Okay? Well, I think something's wrong. Why we have three lines, but where is our dy2? It didn't provide dy2. Should have a dy2. Okay, this paper, something is not right. Right?
What is this y?
It didn't provide dy2. I will provide dy2, okay? Should have a yd2, okay? You read
Maybe it's the last line is y.
last and y2, but they didn't put a dy2 equal to something. That's not right, okay? dy3 is right, okay? Now, I will explain to you, okay? yd3 is right, equal to nvith y dot 2 equal to, our equation is 3e7. I hope you understand what this 3e7 means, okay? That is a number.
3 times 10 to the 7.
Yes, great. Now, we give you equation at the very beginning. So dy1 equal to here, minus 0.4, okay, multiplied by y1, add 1e4 multiplied by y2, y3, this is right. This third one is also right. y2 multiplied by y2, okay? And we need to add the second one, okay? Second one is like this, okay? Second one in the middle, okay? Second one is, should be, okay, we can apply this document, we can add this. yd2, okay, equal to
The last line.
nvith y dot 1, okay? Start from 0, so y dot 1. And the function is not that last one. The function should be this guy, here, the longer, okay? It's not this yd1 minus yd2, okay? It's like should be this guy, okay? 0.04, right? So should be 0.04 multiply y1, okay, minus 1 dot 0 e4 multiply y2, then multiply y3, and minus. And great. Basically, this exactly is dy1 minus dy2. Okay. Okay. You can write this, or you can minus yd1 minus yd3. Right? It's the same, right?
Oh, yes.
Yeah. Right. So you don't need
Just
details.
one minus.
That's why this one is the first, this one is. So anyway, normally I'm not doing this, I just give this exactly. Okay? So in this case, you know exactly, then you move this to lower. Okay? Because this one want to minus this, so this should be calculated first. Right? That's
But
why
even if minus, I think some difference.
minus by d1 is the same, no? Is it the same? Minus this.
Times something.
That's it.
This should be.
This part
Yes.
equal to minus this part.
Yes.
This part is minus y d1.
Yes.
So instead of write this long equation, you just say minus 1, right?
Yes.
So make it shorter, right?
Yes.
It's y d1, right? Minus y d3, right? And make it shorter, right? Right? Understand? Okay, this equation is ready. Okay, now we have the equation. Okay, so good, we have an equation. Now we haven't called our VOD solver yet. Okay, so but this time if you compile, this error should be disappeared. Okay, so the first error should be disappeared. Okay, hopefully now no error. Great, now succeed, right?
Still
Now-
3 error.
You have error?
Yeah.
I didn't have error. So what error?
Error is they said
Yeah.
said something here is wrong, but IOPT I really defined here. I can't see something. And this
Are you sure you write it wrong? You write it right?
yeah, the whole
The argument, the number is right or not?
argument.
Yeah. So now I can start call the solve. Okay, first I need to check. Does this CVOD memory return success? Okay, if it's success, I will call solve. If it's not, because you try to create a memory, right? Maybe fail. So this is normally the case here. Now this is create a memory for CVOD solver. Then I need to check this memory. If it's 0, you shouldn't call. Okay, so if this CVOD memory, if it's something is wrong, you shouldn't. If it's not, okay, which means no memory or memory is failed. They, okay, if it's something is wrong, well, it should be uppercase. Okay. Oh, already. Okay, if it's not, you should print something and it should be stopped. Okay, you should print something. Here, you say something is wrong, okay, and stop should be return. Okay, you need to print something. You say print the printf. Okay, print something like said memory allocation failed. For example, here you said CVOD memory allocation failed. Okay. In this case, I will do a return, and then I will return, because I return normally is -1. Okay? Here return 1 is not right. So normally return 0 is success. Otherwise return is wrong. So return -1 or 1 is okay. I prefer negative value. Negative value normally is something is wrong. Here is the, this is the create memory, right? I will check this pointer. Okay, if it's not, which means the memory allocation is failed, so I will return. Okay, now here I can call the solver. Okay, will be solved to calculate our equation. Okay, so I haven't added that yet. So, but I need to compile to see something wrong in case now something wrong. So in this case, this I type is wrong. So MEM. Oops, sorry. So you will see something's wrong because the name is not matched. So good.
I have a very
You still have error?
strange error. Yes.
Compare by this. Okay.
Yeah.
C is exactly the same or not? No? Mine is okay, right?
They said the error C like a C108.
Which error?
This is 3 error.
Oh, delete the, you add something. Where's your headline? Down. I need to find what code you include. Or you include the actual, but this delete these two actions. Reaction is mine, so delete it. So, remove it. Right click, remove it.
Oh,
There should be everything's fine. So if you include the reaction, should remove it.
Why? Oh, okay.
Okay, because the original is running on my machine, not running on your machine. Okay, the folder is different. Now I can start.
And I have another error.
Now we can call.
This one is not initial, but here.
Yeah, it should move down after this because you want to call this. So, yeah, switch.
Oh, switch.
Yeah,
Oh,
switch. Yeah.
yes.
Understand this? Right? You want to use the you should switch. Okay. Okay. Now I can call the solver. So solver CV dance. Okay. NSE.
Therefore, warning.
C.
Nothing wrong.
The warning is okay. You haven't used that yet. This is warning. Okay. So call this solver. Okay, call this CVOG dance. Okay, solver. The memory is here. Okay, we can call this solver. Okay, so we will use linear solver with internal Jacobi. We can provide Jacobi, and you can create Jacobi. But in this case, this solver is pretty smart. They can create this Jacobi for you based on your equation. Okay? In this case, then we will be happy. Okay? Now, next is export our results. Okay, so next part is print out our results. Okay, here print out.
So CV dance gives you a job.
Value. Give us your results. It's very smart. Okay.
Oh.
Now we have the export our results here. Okay. Now the next part is looping and then try to find our results. Okay. We haven't called CVOD yet. Okay. Now here is for loop is calculation. Okay. So here now we need something. We still need a little bit something. Okay. We want now here's the results. Okay. 3 species kinetics problem. Okay. This is just print something.
What's this problem about?
This is a chemical reaction. I don't know what this is. Okay.
Okay.
3 species, which means any function. Okay. As
Oh,
long
I
as
know what they mean. They have 3 chemistry.
Yes. 3 chemistry, 3
equation.
equation, and it will give you the result
Yes.
based on different time. You can see it's for loop.
Yes.
Starting, okay, this is you, and step is should be the 0.4. Okay, so it's okay. Where is my mouse here? Now I will use the for loop, try to call this solve. Okay, use for loop. Normally is the case. Okay, I will use for loop. This for loop. Okay, I will start from I. OUT equal to 1, TOUT equal to 0.4, IOUT equal to, less than equal to 12, IOUT, okay, TOUT. And this we can change, okay? With this step, all these steps, oh, this is not right. Okay. Multiply, okay. T out, multiply, okay. T out start, okay.
Get some next.
Now we try to call our server. This is the time we call server. We will check the flag, return flag. The CVOD server. And this CVOD server need this memory. MEM TOUT Y and it's time MORMA.
What's this flag about?
This is a return flag. If flag is
true or false?
if flag is not equal to success, which means your calculation, your equation may be not converged. Okay? So you need to check the flag. Okay?
Oh.
If not a success, it's a fail.
Yeah.
If it's a success, you can print the value. Okay? I should move this switch, print and the flag. Okay? So
Is the
the flag is returned, right?
It's integer.
It's an integer.
Oh.
It's an integer. Okay, normally it's integer. Okay. So what have error? What error? I type something wrong. IOUT equal to 1. TOUT equal to 0.4. IOUT next. Oh, this is not right. This. Okay. And this. Okay. So now it's okay, right? Okay, we will check flag here. If the flag is not equal success, we just stop, okay? Which means your calculation is right, okay? If it's not equal to success is constant, we define somewhere, okay? SUCESSU. If it's not equal to SUCCS, okay? SUCC. If it's not success, then you can print something, okay? And then you should return something here. Okay? If it's not, I suggest you should break. Break, do you know break means here? In the for loop,
Break
if
out.
you break, it will break the loop. Okay, stop the for. Okay. Anytime if you found the value is not right, just stop. But before we stop, we should print something. Say CVOD fail, for example. Give you the flag value. Okay, this is basically the print means. Okay, we need to print something. Okay, tell the user something is wrong. Okay, it says CVOD is wrong, right? CVOD fail. Okay, cannot calculate your flag value also normally print out. Okay, this is a number, so D. Okay, and then this give you say here the flag. Okay, FLG. Okay, good. So if it's right, then we just print the data. Okay, we haven't printed the data yet. Okay. So no error. So now I can print the data here. This print the data very simple. Okay, PRINT.
What's the E in this regular expression?
What is it? Where?
Here is, I forget in regular expressions what is E. This is a regular expression.
E, yeah, this is just E is, well, E is here just 10 something, okay?
Oh.
This is
Scientific notation.
scientific notation, okay?
Oh.
We are not print, we just exactly print that, yeah. So you don't know the format, right? Here.
Oh, format.
This
This is print format.
Yeah, print the format.
But
yeah.
I forget what is.
T equal to, no, this will give you scientific,
Yeah.
you will display E, okay?
Oh.
Now this is basically maybe use type Y equal to 14.6E and 14.6E 14.6E. This is scientific notation to send out, okay? And we will print the 4 numbers. And what for number? So here it give you each individual. You can go to set them, okay? And the value should be 1 is type T. 1 is Y1, Y0, Y1, Y2, okay? That's what we're interested, right? V I T H Y 0. V I T H Y1. V I T H Y2. Right? Oh, Y2, not this. So we want to print this. So it's success. Okay. Now once we finish, we should clean up our memory. Okay. So the last part is clean up our memory. So free. So the vector should be free. Okay. V N now F R E free. Free Y. Y is a vector. Okay. N V free is A B S T O L, and we also free the CVOD solver. Okay, so this CVOD solver, they have a lot of memory, so we need to free it.
What if
Done.
we forget to?
Doesn't matter if you finish your code, the code stops and then it's free. So free. Doesn't matter. Okay. And last one is if you print out some, it says statistics value, right? What this value is. So basically, if you didn't print out the last one, this will give you some extra information. So it means how many loops, how many this, how many that. So that's the calculation statistics information. Okay. If we don't type this, then we basically already done. Okay. So if this, then no error, then we can run it. Okay. If you run it, okay. Oh, DL. What's going on? I don't have a DL. My system have a problem. So last night I need add something. So what is DL? COLADERAD.dl somehow I disappeared. Okay. So I found today I cannot run it out my program because we used to do last night I did something wrong. So what is this VS7, which is exactly this one, this version. I deleted something.
Oh, my wrongs.
What about you?
Yes. I should.
Did you compile this wrong?
No, works well. Oh, a system pause. And I want to pause to actually already wrong. But it's
Did you have
too quick, so I want to pause.
Oh, yeah, see the value, you already got the value. Great. That is the value. Suppose this function should give you that value. Okay? You put a breakpoint. Or you can put a breakpoint like a pause, P-A-U-S-E. But
Yeah,
you
what
know,
is
stop
this?
it. Huh?
This.
No, that's it. You should pause, P-A-U-S-E. Just pause is a function, not a system pause. Pause.
With this one?
No, this one. Okay, it's fine. Then you can use, use a breakpoint. Okay. If it's not working, delete this.
Delete.
I don't have a DL to run in this code, so I will figure out it tonight. Okay.
Right.
Because I didn't try this. Here you can try, for example, one way is put a breakpoint in here. Okay.
Oh.
That's one way. Another one is, and let me try have a PAUS here. Have this or not? Maybe that.
So actually, each interval they can bring.
So no pause, PAUS. So okay.
Should work. Sometimes works. Sometimes they have. Yes.
Maybe it did include something. Okay. We don't include the pause. Okay.
Oh, maybe you like not a pre-compile,
Yeah.
but the pause is pre-compile.
Maybe you need like standard library, so probably need a stdio.
Fine.
Let's see, do we need to include that one? Let me see.
STDI。
Okay, I'll include typing.
STDI。
I have the house now, I don't remember. No? And then you can go somewhere to find the house which include file. So Google, and it should be okay. Anyway, I also need to add. Well, the actual is just the calculation information, the statistical information for calculation. And the suppose should be, now, give you, this code I will explain to you, okay? This code is a very good code. For example, if you found some interesting equation model, maybe it's a chemical equation, maybe it's a biological equation, maybe something, the equation similar like the dy1 dt, dy2 dt, dy3, even more, okay? Doesn't matter, okay? This may be more complicated, it doesn't matter, just give this equation. Exactly this one, it will calculate the results, okay, for you, okay? And all you need to do just, now if you have 5, then equation equal to 5, okay? You don't need to change anything. Maybe you don't need to change anything, but you need the initial. Like if you have 3, this one you need 3, okay? Absolute, this you need more, okay? And the function, so it's a slight change. Function change, then it will handle that one. Okay? So this is a general ordinary differential equation solve. Can solve any ordinary equation, okay? Ordinary differential equation. Okay. And this is give you like just a numerical. Okay. So if I said like we have a model, you use like a blood-brain barrier. Maybe they have 60 this equation. Doesn't matter. Same thing, right? 60. This may be pretty complicated. It doesn't matter. Okay? See?
Oh.
You just write this main function and
It will for
yes, it will work for you. Okay? And but the problem is if you 65 or 60, the data is too many data, big table, right? We can either put the data to the Excel, okay, or we can use some kind of software to display the data. To display like picture, okay? Not just code. We call visualization. Okay, visualize your data. Okay, use similar. You remember beautiful curve? Not code. Beautiful picture, 2-dimensional picture to display your solution. Maybe some 3-dimensional. Okay. So this is one way how to use CVD solver to help us to solve ordinary differential equation. Okay. This is one way to calculate this equation. Another one, we can provide a Jacobi matrix here. And then here, a little bit of difference. Here, instead of we use now, we will provide Jacobi matrix function name here. Okay, somewhere here. And then, which means user provide Jacobi matrix. Okay? So, see this function? What is this function?
provide what?
Now, see this one?
Yeah.
User can provide a Jacobi function. This is dense measure the Jacobi function. We can provide. Okay? In this case, now, which means the system will create for you. Okay? Maybe you don't need to provide. Okay? Or you like, you can provide. Okay? Because the system is very smart. They know how to create a Jacobi matrix. You don't. So this is the guy. wrote this function, designed this algorithm, they understand this chemical equation, and figure out the Jacobi measures. So it's a very smart program, right? So source code also give you. So if you want to publish a paper based on this, unless you change something inside here, make this even better, then you have a contribution. Otherwise, you don't have a contribution, right? So that's the issue. So here, if we really understand this, how calculate this, and we can create our own, make this even better, that's a big contribution. Okay? So that's why you want to publish some like a good paper, you need to spend a lot of time to try to make other people's work better. Okay? And this basically is already pretty useful. So now today we talk about if someone give you this source code. Now I will show you, not related to this. Okay, I will show you if someone give us library, just give us header file and give us DLL, right? I don't have a source code. This is normally the case because people don't want to give you source code. You can copy the source code, so they scale. They don't want to give you source code. They can give you the DLL. Then how to include in your project? Okay, I will show you. Okay, we still have some content, so here. So I will show you how to do this. Okay. So for example, I have a financial software. So Shanghai Exchange, they will provide this code. Okay, I will show you where it is. Okay. For example, I have a trading software, Shanghai Exchange. So this Chinese, they will provide a couple of API. Okay. Normally, what API they will give you is normally the case. Okay, it will give you a couple of header files. Okay, and it will give you a couple of DLL. Okay, we know this to DLL. And also it will give you library. Okay. DLL, when you run your code, this will dynamically load to the memory and run it. Okay. When you build the code, you will use this library. Okay. So how? Okay. If we give you header file, give you DLL, give you library, then you want to create a code how to use other people's API. Okay. This one, because I don't need to know what the details, how you implement your code. I don't care about the code. I care how to use your code. Okay, so this header file give you enough information. We call interface. Okay, give you enough information, interface, how to call your functions, right? Which argument in each different position, right? Which argument you should. So it will give you enough information. Okay? Normally it will give you some structure. So what structure you should use. Okay? In this case, if you have a project, so I will show you the project and how it's doing. Okay? For example, I have a project. Okay? If you create a project where this should go, okay? In this case,